Hey everyone, it's Gus from PyMyLifeUp, and today I'm going to show you how to connect a photoresistor sensor up to the Raspberry Pi. Also show you how you can access it in a simple Python script so you're able to gather and use data from it. This is yet another sensor that I will be looking at incorporating into future projects, such as a light activated alarm clock. The circuit we are going to make for this tutorial is super simple and is great for anyone who is just starting out with circuitry. The light dependent resistor, or also known as the LDR, is the most important piece of equipment in our circuit. Without it, we wouldn't be able to detect whether it is light or dark. In the light, this device will have a resistance of only a few hundred ohms, whilst in the dark it can have a resistance of several megaohms. The 1 ultrafiltration or UF capacitor in our circuit is there so we can measure the resistance of the LDR sensor. A capacitor essentially acts like a battery, charging up whilst receiving power and then discharging when no longer receiving power. Using this in series with the LDR, we can work out how much resistance the LDR is giving out, thus whether it is light or dark. We do this by measuring the time it takes to charge the capacitor. The longer it takes, the higher resistance of the LDR. I will now quickly go through how to put this circuit together. If you rather just follow a circuit diagram, then you can find it over at PyMyLifeUp.com. The pin numbers I'm referring to is the physical numbering of the pins. This is the logical order, 1, 2, 3, 4, for example. First connect pin 1, that's a 3.3 volt pin, to the positive rail on the breadboard. Next connect pin 6, that's a ground pin, to the ground rail on the breadboard. Now place the LDR sensor onto the board and have a wire go from one end to the positive rail. On the other side of the LDR sensor, place a wire leading back to the Raspberry Pi and hook this into pin 7. Finally, place the capacitor from the wire to the negative rail on the breadboard. The negative pin is usually marked on the capacitor itself. The code for this project is pretty simple and will tell us roughly whether it is light, shady or completely dark. The biggest problem we face with this circuit is the fact that the Pi doesn't have any analog pins. They're all digital, so we can't accurately measure the variance in resistance on our input. Instead, we will be measuring the time it takes for the capacitor to charge and send the pin to high. This is an easy but inaccurate way of telling whether it is light or dark. To begin, we import the GPIO package that we'll need to be able to communicate with the GPIO pins. We also import the time package so we're able to put the script to sleep for a little bit. We then set the GPIO mode to GPIO.board. This means all the numbering we use in the script will refer to the physical numbering of the pins. Since we only have one input-output pin, we only need to set one variable. Set this variable to the number of the pin you have acting as the input-output pin. We now set up a function called RCTime that takes a parameter called pin to circuit. In here we initialize a variable called count. We will return the value once the pin goes high. We then set our pin to act as an output and then set it to low. After this we put the script to sleep for 10 milliseconds. We then set the pin to become an input and then we enter a while loop. We stay in this loop until the pin goes to high. This is when the capacitor charges to about 3/4. Once it goes high, we return the value to the main function, where you can use this value to turn on and off an LED or activate something else, or just log the data and keep statistics on any variance in light. Now let's get it working on the Pi. Whilst all the software package should be installed, in some cases it may not be. If you want to learn more about the GPIO and how to update and install the software, then be sure to check out my tutorial on setting up the GPIO pins on the Raspberry Pi. Now you can simply download the code by using wget. The following code will do exactly just that. Sudo wget, then the URL to the download. You can get this over at PyMyLifeUp.com. Alternatively, you can just copy and paste the code. Just make sure the file is a Python script. For example, sudo nano light_sensor.py. And then in here, just copy and paste the script. Finally, run the code by using the following command. Sudo python light_sensor.py. I hope you now have the script working and receiving the data that correctly reflects the changes in light on the sensor. As you can clearly see, mine is reacting correctly. When in the dark it is returning high numbers, whilst in the light it is returning low numbers. There are countless of uses for a light sensor in circuitry. I will just name a few that I thought of when I was doing this tutorial. A light activated alarm. I mentioned this one earlier, but you can use the LDR to detect when it starts to get light, so you can sound an alarm to wake up. If your program and sensor is accurate enough, you could have it slowly get louder as it gets lighter. A garden monitor. A light sensor could be used in a garden to check how much sun a certain area of the garden is getting. This could be useful if you're planning on planting something that needs a lot of sun or a lot of shade. There is so much you can do with this cool little sensor, but keep in mind, if you require something a little more accurate than a photocell, try looking at something like the Adafruit high dynamic range digital light sensor. I hope you have been able to set up this Raspberry Pi light sensor without any issues. If you do come across a problem, have feedback, I have missed something or anything else, then feel free to drop a comment below or over at PiMyLifeUp.com. Until next time, have a good one. Looking for more Pi projects to do? Check out these 21 awesome Pi projects that anyone can do. Don't forget to subscribe so you can stay up to date with the latest and greatest projects, guides and much more.